हरि करना।
Before we jump into the probability and explore the probability fundamentals, and then before we do some experiments, so most of you may ask, so you are focusing too much on mathematics, probability, statistics, and other stuff. But what's there for me as a data scientist to learn probability? How does it help me to handle machine learning algorithms or machine learning models very well? Will it help me or will it not? That's what I'm going to show you. The importance of probability in machine learning. So I've taken the in four important aspects. The first one is uncertainty modeling. Uncertainty modeling. Probability theory is the basis for modeling uncertainty in data. So ML algorithms deal with large amounts of data and make predictions based on this data. However, data is often incomplete or contains noise, and ML algorithms need to account for uncertainty in the data. So, probability theory provides the framework for modeling this uncertainty and making probabilistic predictions. What? Making a probabilistic predictions. Let me show you. So, applications of probability in ML. So first one is uncertainty modeling, uncertainty modeling. So that's so as an example of uncertainty modeling in ML, which is a natural language processing. That's what natural language processing. Okay, NLP tasks. As an example of uncertainty modeling in ML is natural language processing NLP tasks, such as what all those tasks. I'm going to write it down for you, such as speech recognition, or machine translation. In these tasks, the output is inherently uncertain, as there can be multiple possible interpretations of a given output. So what all models we use, I'm going to write down. So the models that we use for this, it could be the probabilistic models, such as hidden Markov models. Hidden Markov models. In short, we call it as HHM. Fondly we call them as HMMS. HMMS. So, or another model is recurrent neural networks. We know this. This is no, everybody knows about this. Recurrent neural networks. In short, we call it as RNNs. RNNs. So can be used to model the uncertainty in the input and output and make probabilistic predictions. Then we have decision making. Uh, Decision making in many ML applications. Decision making, so such as classification, regression, and clustering. I'm talking about the classification, regression, which are supervised models, and clustering, which is unsupervised model. So we have covered supervised and unsupervised both models. So Data scientists need to make decisions based on the predictions made by the algorithm. So, probability theory provides a way to quantify the confidence in these predictions and make informed decisions based on the level of uncertainty. We have seen NLP, we have seen ML, simple ML algorithm, such as ML applications such as classification, regression, and clustering. Almost everywhere, probability is there. Okay, so let me give one example for you so that you will believe, or else you won't. For you, probability means just another mathematics from 11th or 10th standard. No, not at all. You have to change your perspective first. Okay, the second one, sorry, let's go up. Second one, so decision making. Decision making. So, in classification tasks, let's take a classification task example. So, of course, it will be used in regression. It will also be used in unsupervised, that's clustering also, but I just want to take classification tasks as example. So, in classification tasks such as uh, spam detection, I think Google uses in their Gmail, or even in Microsoft in their Outlook. So spam detection. So the ML algorithm needs to make a decision based on the input data. The output of the algorithm can be a probability score indicating the likelihood that the input belongs to a particular class. So the decision can then be based on a threshold probability score such as 0.5 or a different threshold depending on the specific application. Then we have Bayesian modeling. After the decision making, we have Bayesian modeling. Bayesian probability theory is a particularly important in ML as it allows for the incorporation of prior knowledge into the model. Incorporation of prior knowledge into the model. So these are called priori and posteriori. There are two types of probabilities when it comes to the Bayesian modeling, priori and posteriori. It uses the priori and calculate the posteriori. So Bayesian models are useful for a range of tasks such as parameter estimation, model selection, and hyperparameter tuning. Remember these words: parameter estimation, model selection, and hyperparameter tuning. Very, very important. Hyperparameter tuning. So, an example of Bayesian modeling in ML is in the context of hyperparameter tuning. So, hyperparameters are parameters of an ML algorithm that are set before training, such as the learning rate or the number of hidden layers in a neural network. So these are called as the hyperparameters. So Bayesian optimization can be used to find the optimal set of hyperparameters by incorporating prior knowledge and iteratively updating the probability distribution over the hyperparameters based on the observed performance. And these hyperparameters are very important because these hyperparameters are parameters of an ML algorithm that are set before training, such as the learning rate or the number of hidden layers. Learning rate for ML application, or we can say it as even your number of hidden layers when it comes to the neural networks. Okay, it could be recurrent neural network RNN, or it could be concurrent neural network. So whatever it may be, so hyperparameters are very important. So it is nothing but a parameter of an ML algorithm that are set before training, such as the learning rate or the number of hidden layers in a neural network. So this Bayesian optimization can be used to find the optimal set of hyperparameters by incorporating prior knowledge and iteratively updating the probability distribution or the hyperparameters based on the observed performance. We'll see one example when we look into the Bayesian modeling. Then we have statistical inference. So probability theory is also essential for statistical inference, which involves making predictions about a population based on a sample of data. So this is important in many ML applications such as hypothesis testing and confidence interval estimation. So then in hypothesis testing, an ML algorithm might be used to determine whether a certain effect is statistically significant or whether it is likely due to chance. So probabilistic models such as Bayesian models or frequentist models can be used to perform hypothesis testing and calculate the p-value, which represents the probability of observing the effect given the null hypothesis. So, in summary, probability is crucial for data scientists in machine learning because it provides the theoretical framework for modeling uncertainty, making informed decisions, incorporating prior knowledge, and performing statistical inference. So that is the reason for us the probability is very, 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 very important. So I will try to make it much more interactive and much more visualized so that it would be very easy for you to understand. So I'll make it empirical. I will do experiments so that it would be very easy for you to grasp it.